Lab 9, Properties of Molecular Compounds. Background information. Ionic compounds. High melting point and high boiling point are two properties of ionic compounds. These molecules are held together by the electrostatic forces created by oppositely charged ions. These molecules form a lattice structure, and the forces within it require much energy to overcome. Remember that boiling and melting are physical changes. Molecular compounds. Low melting point and low boiling point are two properties of molecular compounds. The intermolecular forces in these compounds require little energy to overcome. The covalent bonds within molecular compounds do not break, but the intermolecular forces holding the molecules together can be easily overcome at low temperatures, causing the compound to melt or boil. This is a physical change. Continuing to heat a molecular compound or heating it at a high temperature may result in a chemical change. Materials. For this lab, you will need sodium chloride and sucrose, 2 small beakers, about 100 to 150 milliliter, 2 beaker tongs, safety glasses, 2 Bunsen burners, 2 ring stands with rings, 2 wire gauze, and a lighter. Procedure. Don't forget your safety glasses. Using a small scoop, add a small amount of sodium chloride and sucrose each into a small beaker. Place each beaker upon the wire gauze on the ring stand and light the burners. Okay, so we're going to speed up the clock at the bottom of the screen in just a moment, and you're going to want to watch the beakers very closely, especially the one on the right. The change will be rapid. Set a 3-minute timer. Observe your beakers for 3 minutes. Then you're going to turn off the burners, remove your beakers using beaker tongs, and allow them to cool. And if you noticed here, the beaker on the left is now smoking, and that's actually because the glass was so hot it burned the rubber on my beaker tongs just a little bit. Actually, both beakers did, but the one on the left was worse because I grabbed it lower down, closer to the bottom. Data and results. Sodium chloride. No change. The beaker was hot enough to melt the rubber on the beaker tongs and scorch the cork pad. But as you'll note, the sodium chloride looks pretty much the same. Now the sucrose, on the other hand, it very quickly melted. And it happened so quickly you may not have been able to see it in our fast forward there. But it changed color from white to clear, clear to golden, golden to brown, and brown to black. It smoked. It changed from white crystals to black ashy substance. Analysis and conclusion. Why didn't the sodium chloride melt or boil? There are strong electrostatic attractions, strong bonds, between positive and negative ions, and it takes a lot of energy, heat, to overcome them. All ionic substances have high melting and boiling points. Sodium chloride is an ionically bonded compound. Why did the sucrose melt, and what happened to it after that? The weaker intermolecular bonds of the sucrose were easily overcome by the energy, heat of the Bunsen burner's flame. This caused the substance to change from a solid crystalline structure to a liquid, melting. When sucrose is heated beyond the melting point, the molecular bonds begin to break and chemical reactions occur, creating simpler sugars and then other types of molecules. These compounds react with the surrounding oxygen, and eventually the bulk of the oxygen and hydrogen in the sucrose forms into gases, leaving behind black carbon. Sucrose is a covalently bonded compound. Sodium chloride's melting point is 800.07 degrees Celsius or 1473.3 degrees Fahrenheit. Sucrose's melting point is 186 degrees Celsius or 366.8 degrees Fahrenheit. And here's an extension for you. You now know the first step in making caramel. Why not learn the rest? I got this recipe for you online, and I am going to share some of it here. I won't read the slides. I'll give you time to read them yourself or screen capture. And I'll go ahead and actually link this website to the lab in case you want to read through it yourself and try your hand at making some homemade caramel.